Today, lesson 8C, scale factor and similar figures. Now, we sort of hinted at this idea, several weeks ago. Today, we finish off that idea and go into more detail on what we're really talking about. So we're going to do some practice of finding the side length and perimeter and area of similar figures and kind of explain how all of those things fit together. All right, so let's get started here. Some background knowledge as usual. Similar figures, these are figures that have the same shape but not the same size. So in other words, one is either an enlarged version of the other or a reduced version. In this case, if we enlarge each side by 2 or double each side, we have another similar triangle here. And we ran into that and talked about that yesterday in some of the different situations. And then before, this is the part we hinted at, and that's the scale factor. Scale factor is the ratio of any two corresponding side lengths in two similar figures. So there's really two different ways of looking at that situation in this picture. One way to look at it is that this shape, the sides are twice as long. So in a case like that, the scale factor would be 2. The other way of looking at it is the reverse of that. In other words, this rectangle, the side lengths are half as big. So if we multiply these side lengths, you can think of that as the constant multiplier if you want to, we could get to what the other sides would be. Now, how to find those is with similar, or with ratios and trying to see if we have equivalent fractions there. And then we also worked about how to find missing sides to make similar figures. So side x, in order to find that, one way is to think about this in terms of a proportion. 18 over 72 is equivalent to 7 over some side that we don't know. And we've talked about lots of ways of solving proportions, and I've mentioned this over and over and over again. I know some of you were taught cross-multiplying. You weren't supposed to be taught that way, but regardless, we just need to know how to solve a proportion. And so in this case, that missing side is 28, and so now we really do have a situation where we can find the scale factor and they are similar to each other. And so the scale factor from left to right, we're going to go from the left-hand shape, which is the smaller rectangle, to the larger one. And so we have 18 over 72, or the 7 over 28. They both simplify to 1/4. So the left-hand rectangle, the sides are 1/4 as big as they are on the one of the rectangle on the right. 1/4 as big. If you flipped it around, thinking of it the other way, the side lengths of the right-hand rectangle are 4 times as big as the one on the left, and so on. And then we even did some triangles, and it's really the same idea. We have a proportional relationship here if the triangles are similar. So we find our missing side, and then we can find scale factor from that as well, where the scale factor here is 6/5. The side lengths of the triangle on the left are 6/5 times as big as the ones on the right. All right, and then we did some problems where I gave you a rectangle and a grid, and I made you increase or reduce the sizes of the side lengths. So here was one that we did earlier in the year, where I told you to draw a rectangle where the side lengths were 3 times as long, and so you had to do something like this. And then I had you find the perimeter of each, because we were trying to see the relationship between not only the side lengths, which are 3 times as big, but also the perimeter and the area. And what we saw was the perimeter of the new shape is 3 times as big, but the area is 9 times as big. And of course, if we're increasing each of the sides by 3, the scale factor is 3:1. Now, we're at our official number 1 for today. We're going to do this without pictures, is basically what we're trying to do here. So I give you an original rectangle with a base of 3 centimeters and a height of 4 centimeters. And we're going to use the scale factor 2:1. So that means we're going to increase each of the side lengths by 2 times. And then we're going to compare the perimeter and the area to both. Go ahead and do that. Now, there's no doubt, I know, all of you know how to find the perimeter of a rectangle and the area of a rectangle. But here's the deal. By the end of this lesson, you should know how, if I give you a scale factor, you should know what the area of the new shape is without even thinking about what the side lengths are. That's the whole point. We're trying to quickly see that pattern. So here, the original rectangle has a perimeter of 14 centimeters, and the original one has an area of 12 square centimeters. So here's what I'm saying. If I give you the scale factor, you should be able to tell me what this is and what this is without thinking about what the side lengths are. That's what I'm saying. How do you do that? How do you do that? That's the question. So let's do a couple of problems, and then hopefully we'll see that pattern. Well, the side lengths, since we're increasing it by a scale factor of 2 to 1, they're basically each doubling. And so the perimeter of that new rectangle would be 28 centimeters. And the area of that new rectangle will be 48 square centimeters. The scale factor is 2 to 1. So the side lengths are 2 times as big. The scale factor is 2 to 1. Notice that the perimeter is also 2 times as big as the original one was. But that's not the case for the area. How many times bigger is the area? It's 4 times bigger. And so the question might be, well, why is that? Well, that's part of what we're dealing with today. Okay? All right, everybody do number 2. Now the scale factor is 1/4. So you're making the side lengths 1/4 as big. So you're reducing the size. And if drawing a rectangle helps you, there's nothing wrong with that. But we're trying to get to that point where we don't have to really take a look at an actual rectangle to deal with all of these things. All right, let's take a look at number 2. Scale factor is 1/4, so we're making the side lengths 1/4 as long. So in the original rectangle, the perimeter is 96 millimeters, and the area is 512 square millimeters. We're making the side lengths 1/4 as long. So in the new rectangle, it is going to be 4 millimeters by 8 millimeters. That gives us a perimeter of 24 millimeters for the new rectangle and an area of 32 square millimeters. So what's the relationship between all of these things? Well, the scale factor is 1/4. So the side lengths of the new rectangle are 1/4 as big. The perimeter is also 1/4 as big. However, the area is not 1/4 as big. Have a quick conversation about what it actually is. Go. All right, so the conclusion is it is 1/16 as big, and it is, because it's 1/4 basically times 1/4. So 1/16 as big, and I didn't mean to zip past that. 1/16 as big. So here's what I want you to do in number 3. I want you to find the perimeter of the original and the area of the original, and then I want you to find the perimeter of the new and the area of the new without finding the side lengths. Okay? Scale factor is 3, which is the same thing as 3 to 1. Okay? Go ahead. So I asked you to find the perimeter of the original and the area of the original, and then try and find the perimeter of the new and the area of the new without the side lengths. I'm going to go ahead and fill in the side lengths, but you don't really need those. If the scale factor is 3 or 3 to 1, the perimeter will be 3 times as big as the original one. Whereas the area will not be 3 times as big, it will be 9 times as big. And so that's what we're trying to see today. So back side of your notes, a quick summary of this whole thing that we're talking about. If you know the scale factor is 2 to 1, the side lengths will be twice as big, the perimeter will be twice as big, but the area will be 4 times as big. If the scale factor is 5 or 5 to 1, the side lengths will be 5 times as big. The perimeter will be 5 times as big. The area will be 25 times as big. If the scale factor is 1/3 or 1/3 to 1, the side length will be 1/3 as big. The perimeter will be 1/3 as big, but the area will be 1/9 as big. And so a little formula, if you want to think of it that way, if the scale factor is n to 1, where n represents any number basically, The side length will be n times as big. And we have blank areas to fill in here. The perimeter will be n times as big. But the area will not be n times as big. What would it be? N to the second power. Good. That's really what's happening. Regardless of whether n is a fraction or a whole number. But in case you're confused by the fractional part, if it's 1 over n, the side lengths will be 1 over n as big. The perimeter will be 1 over n as big, but the area will be 1 over n squared as big. So now we're going to do some problems where we're not filling in a table. I'm going to give you one piece of information, and you've got to find something else. Okay? So let's take a look at number 4. Number 4 states that rectangle KGRT has an area of 12 square meters. It has been reduced by a scale factor of 1/2 to 1. What is the area of the reduced rectangle? Find it, please. We started with 12 square meters. We're making it, or we're reducing it by a scale factor of 1/2, but we're dealing with area, so it's essentially going to be 12 times 1/2 squared. We're reducing it by a scale factor of 1/2, which means we're really, in terms of area, 1/2 squared. And so that would be 12 times 1/4, which is 3 square meters. All right, go ahead and do number 5, 6, and 7, and then I'll get back to you in a few minutes. Number 5, triangle ABC has side lengths of 3 feet, 5 feet, and 6 feet. It's going to be enlarged by a scale factor of 5 to 1. So that means the side lengths are going to be increased by a scale factor. And so we're going to have side lengths of 15 feet, 25 feet, and 30 feet. Now remember, whatever the scale factor is, the side lengths are affected the same way. The perimeter is affected the same way, but not the area. The area is affected by the scale factor squared. Number 6, rectangle WQER has a perimeter of 48 miles. It has been reduced by a scale factor of 1/6 to 1. What is the perimeter of the reduced rectangle? So the perimeter will be affected by 1/6 as well as the side length. So that would be 8 miles for the perimeter. And number 7, rectangle LAME has an area of 75 square meters. It has been reduced by a scale factor of 2/5 to 1. What is the area of the reduced rectangle? So same idea here, but you have to pay a little more attention to what you're doing. Jack, what do you think it is? It's what? How'd you get that? I mean, I know how you got it, but how'd you get that? Right, well, what's 2/5 squared? 4/10? It is? 2/5 squared is 4/10? What's 2/5 squared? 4/25, right? Okay. So it's not going to be 3. What do you think it is? It's going to be 12 square meters, because 75 times 2/5 squared gives us 75 times 4/25. If you want to do a little bit of cross-reducing right here, you of course can, and that would give us 12 square meters. All right, we are finished for today.